All right, let's add rational functions here. As you can see, I have 2 over x squared minus x minus 20 plus 3 over x squared plus 7x plus 12. The key to this whole thing with rational functions is just factor everything. So let's look. 2, we can't factor that. That's done by itself. But x squared minus x minus 20 does factor, and it factors nicely to x minus 5 and x plus 4. That's negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. And we're going to add that to 3 over, well, x squared plus 7x plus 12. That's pretty straightforward to factor. That's going to be x plus 4 and x plus 3. All right. So now I have it factored. I can actually look and see, do they have anything in common in the denominator? What do they don't have in common in the denominator? So we can actually create a common denominator, because as we add fractions, we must have a common denominator. All right, so I see that they have the x plus 4 and the x plus 4 in common, so I don't have to mess with the x plus 4. But I do notice that this bottom is missing this x plus 3. So I'm going to multiply it by the number 1. The number 1 that I'm going to set up is going to be x plus 3 over x plus 3. And I'm going to multiply it on the side, because if I multiply by the number 1, I don't actually change this. I'm changing the way it looks, but it doesn't change the value. And of course, x plus 3 divided by x plus 3 is just 1. We're going to do the same trick with this x minus 5, because that's what's missing in the denominator here. I want to multiply this by x minus 5 over x minus 5. You can see I'm still just multiplying by the number 1. Pretty fancy with it. Gotta love our school bells on a Sunday. All right, so from here, we're just going to put everything together. We're going to do our multiplication first, because PEMDAS says we have to multiply before we add and subtract. So I'm going to have 2 times x plus 3 plus 3 times x minus 5. And that's all over my common denominator, which is right here. It is shared in both of them. They're both identical. So my common denominator is x plus 3, x minus 5, and x plus 4. Of course, at this point, I can look here, because you know I'm going to ask you for the domain. You know x cannot be negative 3, positive 5, or negative 4 by simply setting your denominator equal to 0. So negative 3, 5, and negative 4. Just put a note over there, so when we go to write the domain, we already have it written down. Now, we're going to simplify the top. I could care less if you do anything with the bottom, because it's going to be a trinomial, and it just gives you another step you can make a mistake on. So just leave it in factored form like this. It's fine. All right, so we're going to do hippity-hoppity, distribute a property both places. And I'm going to get 2x plus 6 plus 3x minus 15 all over my denominator of x plus 3, x minus 5, and x plus 4. Okay. Combine like terms. 2x and 3x gives me a 5x. Let's see, 6 minus 15, I'm pretty sure is negative 9. And that's over my same denominator, which is x plus 3, x minus 5, and x plus 4. Voila, I'm done. Piece of cake. No problem. Adding fractions is just like adding rational functions, just as easy as adding fractions. Let's talk about our domain. Our domain is still going to be the normal setup. Our domain is going to be the set of all x's such that x is an element of the real numbers, and x cannot equal negative 4, negative 3, and 5. And you're done. Hi, I'm Mr. Buzzard, and I'm making these videos as supplemental instruction for my students. If you found these videos actually informative, or they answer the question you're looking for, make sure you hit the like button, and then don't forget to subscribe, and then click the bell to receive notifications for future instructional math videos.